In this video, I'm going to go over some common errors that I've seen when students are trying to verify trig identities. Now, one thing to keep in mind when verifying a trig identity, let's say it's something like as simple as tangent square root of x is equal to sine square root of x over cosine square root of x. Now, when we are verifying this, the regular rules of solving an equation do not apply. For example, if we have 5x plus 3 is equal to 10, the instructions on this equation would say to solve. Now, because the instructions tell us to solve this equation, we know that this is a true statement. So because it's true, we can apply all of the operations that we normally would apply when solving an equation. For example, we could subtract 3 from both sides. We get 5x is equal to 7. We could divide both sides by the same thing. In other words, when we are solving an equation, whatever we do to one side, we can do to the other side. That is not true when we are verifying a trig identity. So when we're verifying a trig identity, again, the instructions would tell us to verify. Now when we're verifying, we cannot assume that these two sides are equal. In other words, we cannot assume that the left side is equal to the right side. Because we cannot make that assumption, all of the things that we were doing over here when we're solving an equation, we can't do those. In other words, we can't perform one operation to the left-hand side and then do the same thing to the right-hand side. That is not allowed when we're verifying trig identities. So let me show you an example or two to illustrate this idea. All right, suppose this is the identity that we are trying to verify. Tangent square root of x times sine square root of x is equal to sine square root of x times tangent square root of x plus sine square root of x. Now, one thing I might do first is on the right-hand side, I notice that I have a sine square root of x in each term. So I'm going to factor that out, and I'm left with tangent square root of x plus 1. On the right-hand side, I have tangent square root of x. Actually, I made a mistake in the original. Hang on, let me fix that. I wanted this to be secant square root of x. Okay, so on the right-hand side, I factored out sine square root of x. On the left-hand side, I have sine square root of x times secant square root of x. Now, if we were trying to solve an equation, or let's say we already knew that this trig identity was true. If it was true, then I would know that the left side is equal to the right side. In which case, I could use the operations that I would normally use when I'm solving an equation. However, since we are trying to verify, or let me say this another way, we don't know that this is true. Because we don't know this is true, I can't just divide both sides by sine square root of x. In other words, I can't just cancel these two sine square root of x's. Okay? So we can't do that. That is one common mistake that I see, is students will cancel terms or subtract terms from both sides. Can't do that. Let's look at a second example of this idea. Suppose this is the identity we're trying to verify. Now, a common urge that students will have is they'll say, oh, I'm just going to cross multiply here. And if we cross multiply, sine x times sine x is sine square root of x. When I multiply these two things together, I get cosine square root of x. When I multiply it all out and simplify, I end up like this. And then this is the same thing as sine squared of x. And then you would have it. Now this is a problem here. Again, we don't know that these are equal to each other. Because we don't know that these are yet equal, we cannot cross-multiply. Cross-multiplying is a shorthand for multiplying both sides of the equation by the same thing. So we can't do that. So how you should go about solving this identity, one thing you could do on the left-hand side is we can multiply by the conjugate. So I can multiply the top and bottom by cosine of x plus 1 over cosine x plus 1. So doing that, I'm not going to multiply out the top. In the denominator, I will multiply that out. I get cosine squared of x minus 1. Cosine squared of x minus 1 is the same thing as using the Pythagorean identity as sine squared of x. So we end up with sine x times cosine x plus 1 divided by sine squared of x. And I can factor out the sine x in the top and one of them in the denominator. So once I cancel out the sine of x, I end up with cosine x plus 1 over sine x on both sides. And that would do it. All right, so to recap these first two examples, solving equations and verifying trig identities, we can't just do the same operations. So we need to be careful about that. The second batch of examples I'm going to show is mainly about the formatting that we want to follow when we're doing some of these problems. All right, suppose this is the equation that we're trying to verify. Now, one thing I see a lot is students not keeping the left side and the right side separated from each other. So what I see a lot is, oh, we have cosine to the fourth minus sine to the fourth of x on the left-hand side. So what sometimes I see students do is they'll say, oh, well, cosine to the fourth of x minus sine to the fourth of x, I can factor that to get cosine squared of x minus sine squared of x times cosine squared of x plus sine squared of x. This is equal to 1, so then we end up with cosine squared of x minus sine squared of x, and that is equivalent to the double angle for cosine, which, oh, that's what we have here. We can bring that down, cosine 2x, and then voila, we have it. Now when I look at some work like this is really confusing to me because I see these equal signs lined up, but this work right here is actually coming from the left-hand side of the original equation. How it's written, though, it makes it look like what is written here is coming from the right-hand side because it's to the right of these equal signs. So how you would want to do this is all of this work that's written here should be under the left-hand side of the equation. So now notice all of the equal signs line up, and all the work that's coming from the left-hand side is to the left of the equal signs. And then at the very end, these are equal to each other, exactly. All right, and then let's look at one last example of this idea. So with this identity, what I also see students do is they'll look at cotangent to the fourth of x, and they'll be like, oh, well, that is equal to cosine to the fourth of x over sine to the fourth of x, and that is equal to cosine squared of x times cosine squared of x over sine to the fourth of x, and that might be equal to 1 minus sine squared of x, I'm running out of room, over sine to the fourth of x, etc. And they'll just keep writing equal signs along the right-hand side there. You don't want to do this either because all of these steps should be written below the cotangent to the fourth of x. Okay, so we want each individual step to go directly below the previous expression, and we want all of our equal signs to line up. Now the reason we don't want to do this is because it's unclear if each of these steps represents just the right-hand side, or if together these two are coming from both the left and right side. Okay, so I just want to be clear again, each equal sign should be written vertically, and everything that we do on the left side should fall on the left-hand side of the equal sign. Everything we do with the right-hand side should fall on the right-hand side of the equal sign.